Okay, we are officially starting the chemistry unit. So all the biology units start with section 1 point whatever. Chemistry, we're ignoring 2.1 because it's just safety. We've already done that, so we're starting with 2.2. Part 1, there's going to be 6 of these. So main concepts covered, we've already talked about this briefly. It's going to be structure of atoms and molecules, naming of compounds and writing chemical formulas. Both of these should be mostly review. Rearrangement of atoms in chemical reactions, energy transformation in chemical reactions, acid-base chemistry, and then nuclear energy and decay. This one we might not get to, just based on timing, because in order to not do literally twice as much as we would do in a normal class every day, some things have to go. These 3 here are going to be new. Vocab and key concepts, you've been asked to do that already. As a reminder, I do have section 2.2 of the textbook up in the chemistry folder on files. Brief history of the atom, we've already watched this video. If you want to watch it again, obviously feel free to copy the link. It's just that crash course one. Okay, so rough timeline of what we've got here. As far as theory of an atom goes, it dates back to 460 BC. So it's like 460 years before 0, when we are currently in 2021. And then Dalton in 1803 AD, so just over 200 years ago. Then not a whole lot changed for close to 100 years. You've got Thomson in 1897, Rutherford in 1912, Bohr in 1913, so all of that's relatively close together. And then you've got a bunch of contributors to the modern quantum cloud model, which is still kind of what we're currently working with. All of these things fit onto, there's a little like timeline specifically going through their discoveries on page 94 for your notes. So make sure that you pause this and write down the names if you haven't gotten them down yet. As far as what we are going to be looking at in this course goes, we're basically going to stop here with Bohr. We're going to look at a simplified version of Bohr. We're going to treat everything kind of mostly the same as you did last year in Science 9, though, where you would have also looked up to the Bohr model. So an atom is the smallest particle of element that still has the properties of that element. Okay? So what that means is you can take oxygen, you can talk about all of the different properties of oxygen, you can talk about its melting point and its boiling point and its color and anything else you want to talk about with it. One single atom of oxygen is the smallest thing that is going to have the properties of oxygen. Atoms are really, really small. If you took 50 million of them and you lined them up end to end, it would be a centimeter. So itty bitty. And when we talk about atom, we're talking about the protons, neutrons, and electrons that together make them up, which are our subatomic particles. So protons, neutrons, electrons, quarks that make those things up are subatomic particles, so they on their own do not have the properties of the element. When atoms join together, they form molecules. And a molecule can be either an element or a compound. If we say compound, it means we're talking about a pure substance that is composed of 2 or more atoms that are combined in a specific way. So oxygen and hydrogen are both atoms or elements, depending on how you want to look at it. And then you can combine them into H2O, you get a compound. Okay, so 2 elements, oxygen and hydrogen, and as a compound you get water, H2O. Okay, so element when there's only one type of atom present, and a compound when there's more than one type of element present. Okay, so take a moment, see if you can figure out what each of these things are. So our terms that we're working with are atom, element, molecule, compound, and mixture. So this is like Science 8 throwback here. Now, you can use these terms on more than one picture each. Okay, so this one right here would be an atom. This one right here would be an element. But that one would also be an element. Okay, this one down here is our mixture. That should be pretty easy to tell. Okay, and then here's where things get a little bit sort of confusing. So both of these could be considered to be a compound. Okay, so that would be a single compound. This would be a group together of the compound. So if you're looking at your water again, you can say water is a compound with a whole bunch of water molecules, or it can just be one molecule. Okay, and then these two, we could call both of these a molecule. Okay, so we've got a lot of crossover in these terms. Mixture is kind of the most clear one, along with atom, and that kind of goes from there. Generally, we use the word molecule if we're talking about things that are covalently bonded, and we use compound if we're talking about things that are ionically bonded, but it gets a little messy. In order to talk about chemistry, we have to talk about chemical changes. So a chemical change occurs when the arrangements of atoms in compounds change to form new compounds. They're generally non-reversible, okay, and they always make a new product. Okay, so rusty nail, cooked eggs, okay, your end result is different than what you started with. You can't really go back. You can't like unrust a nail. You can remove the rust from a nail, but you can't turn the rust back into nail. Okay, and then all atoms are made up of smaller particles that are considered to be subatomic particles. So subatomic because it's less than an atom. Okay, I'll give you a moment to get this copied down. So our three main types of subatomic particles that we talk about are protons, neutrons, and electrons. I'll go through this slowly because you do need to write this down. Symbol for proton is a P. Makes sense. A proton has a positive electric charge. Protons are always found in the nucleus. And then the relative mass, we'll talk about those in a second, but 1836. Neutron, symbol is an N. It has no charge, and neutron is neutral. It is also found in the nucleus. Its relative mass is 1837. And then an electron, symbol is an E. It has a -1 electric charge. It is found surrounding the nucleus, and then its relative mass is 1. So if we go back to these relative masses, what that means is that our electron is the smallest, and then a proton's mass is 1,836 times greater than the electron's mass. And a neutron's mass is 1,837 times greater than the mass of the electron. So if you took a proton and an electron together, their combined mass would be the same thing as a neutron. And their combined charges would also be the same thing as a neutron, because a +1 and a -1 together make 0. Okay, so our diagram of our atom, we've got our neutrons in blue and our protons in green in the nucleus, and then in red we've got our electrons surrounding it. The nucleus is the center of the atom. Okay, it's comprised of both protons and neutrons, and then electrons exist in the space surrounding the nucleus. The number of protons is equal to the number of electrons in every atom. Okay, not all the time, but if it is an atom, then all the time. Okay, so they're not always equal if it's an ion, can't be equal if it's an ion, but if it's an atom, they are always exactly the same thing. The nuclear charge is the total charge on the nucleus due to the protons, which means it's exactly the same value as the atomic number. So the nuclear charge is the charge on the protons, which is basically based on the number of protons that are there. So the atomic number is the same as the number of protons, which is the same as the number of electrons, as long as you're talking about in an atom. And then atomic mass can be found on the periodic table as well, and that is your average number of protons and neutrons together. Important that we distinguish that that is an average. You will generally find decimal values if you look at the periodic table. It doesn't mean that there's part of a proton or part of a neutron, it just means that you've averaged it out. Okay, so generally our atomic number or our proton number is found up at the top. Our elemental symbol is found somewhere in the middle, super obvious, easy to find. And then our atomic mass is generally underneath, and it is measured in AMU, which is atomic mass units, which is just saying that a proton has a mass of 1 and a neutron has a mass of 1. Because if we go back to those relative masses, they're pretty much the same thing. Okay, so a few examples for you to try. Okay, so what is the atomic number on this? What is the ion charge on this? What is the name of the element? What's the average atomic mass? What's the number of protons? And what's the number of neutrons? The only thing sort of worthy of note is that your ion charge, anytime you just see a negative, it means -1, and just a positive means +1. Okay, so if it's -2, -3, whatever, those generally tend to be pretty obvious. But if it's just a negative sign or just a plus sign, it means that it's a value of 1. Okay, and then you're going to complete this table for different atoms and ions. The first two have been completed to help you. So you've got potassium has an atomic number of 19. It has an ion charge of +1. It has 19 protons, which is the same as the atomic number. And then it has 18 electrons, and then it has 20 neutrons. And you would know that it has 20 neutrons because if you were to find its mass, is like 39.1, I think, off the top of my head, looking at a periodic table. So if 19 of those mass numbers come from the protons, that leaves 20 as your neutrons because protons plus neutrons equals mass. Okay. As far as, okay, and then you go through phosphorus. This one is, you're told, is a charge of 0. And the protons and the electrons match. Okay, then you need to go through and figure out the other ones. So if you have the atomic number, which is the same thing as the number of protons, you can figure out what your element name is. If you have your element name, you can figure out your atomic number, which is the same thing as your number of protons, and so forth. I do want to quickly look at where this value comes from. So I'm just going to pull up a blank slide. And we're just going to take a look at that. Actually, let's look at both of these. Okay, so we have 19 protons, and then we had 18 electrons, correct? Yes. So 19 protons have a charge of +19. Okay, so 19 times a charge of +1. Our 18 electrons each have a charge of -1. If you take those things and you add them up, and you take +19, you add -18 to them, you get a charge of +1, and that's your net charge. Okay, if we look at our, so this was for potassium. If we look at our phosphorus, it had 15 protons and it had 15 electrons. So that's 15 times +1, 15 times -1. positive 15 plus negative 15 is 0. Okay, and then that means our net charge on that was 0, or our ion charge on it was 0. Okay, and that's how you figure that out. Okay, so before you move on to the next video, make sure that you are capable of answering these questions. So it's electric charge on each of the 3 subatomic particles, what 2 subatomic particles have nearly equal mass, which particle determines the nuclear charge, and which 2 subatomic particles are present in equal number in every atom of the same element. If you can answer all those questions, you're ready to move on to the next video.